Hi everyone. Today we start a new chapter. So if you haven't already done so, please open up to chapter 11. So you can go back to Mrs. G's original files that she left you and open up chapter 11. And chapter 11 is coordinate geometry. All right. So we had skipped a couple of chapters when we went forward, and now we're just going to make up and go back and make up some of the work that we did skip over. Okay, so what we're going to do is we're going to focus on three formulas. The three formulas that we're going to focus on, is distance, midpoint, and slope. Okay? Now, once we know what the formulas are, we're going to use them in what we call coordinate proofs. So first, let's make sure that we all remember and understand the basic formulas. Okay. Whoops. Okay, so we're in 11A, coordinate geometry. The three formulas that we're going to be working with is first the slope formula, which is m in your y equals mx plus b, m is your slope, equals y2 minus y1 over x2 minus x1. That's also known as rise over run, right? So sometimes when we're working in a coordinate system, rather than spelling out all of the numbers, we could use just a rise over run, and it might simplify some of the work. Okay, the second formula that we're going to be working with is called the distance formula, and we touched on that a little bit in one of the forward chapters. So the distance formula is d equals the square root of the difference in the x's squared plus the difference in the y's squared. Okay, so as we start using this, we'll talk a little bit more about it. It's really a version of the Pythagorean theorem, right? So if I said Pythagorean theorem is a squared plus b squared equals c squared, let's write that as c squared equals a squared plus b squared, okay? Now, if I square rooted both sides, I would get plane C here is equal to the square root of a squared plus b squared. So the distance formula, the x2 minus x1, is simply a. And again, the y2 minus y1 is the answer, and the answer would be your b. So we might be able to work with that a little bit when we get to the coordinate systems. Okay, the third formula is the midpoint formula. So what is the midpoint of a line? Again, we can do it graphically, but sometimes it's more efficient to know the formula. And the basis of the formula is we want to get to the middle of a line. So the middle of the line, midpoint, is equal to, you're going to have 2 points in a coordinate system. So the 2 points are each going to have an x. You're going to add the x's together and divide by 2. Then you're going to add the y's together and divide by 2. And that's basically you're getting the average or the middle point of the 2 points that you have, which would be your midpoint. Okay? So what are the key words? Okay, your slope is your slant or your rise over run. So we can say slant, or we can say rise over run. Okay? Your distance is your length from one point to another, how far, and your midpoint is what is the middle. Okay? Or if you're bisecting something, where does it get bisected? It gets bisected at the middle. Okay? Okay. I just stopped it. Maybe, would you mind just closing the door?
Sure.
Thank you. Okay, so let's just try a couple of quick examples. Sorry, I just dropped my iPad. All right. Okay, day one, some examples. Find the slope of a line that passes through these 2 points. So the slope of the line. All right, so let's use the formula. Slope equals the difference of the y's over the difference of the x's. Okay, so I have xy. Either one can be 1, either one could be 2, xy. So it doesn't matter which one because the slope will be the same. Okay, so my y values, if I start with this -2, I'm going to have -2 minus -6. So just be careful because this double negative is going to become a plus. All right, so -2 minus -6, 3 minus 5. Okay, this is really a plus over here, so this becomes 4. We have +3 minus 5 is -2. So our final slope is -2. Let's look at it another way in case we were graphing. What does slope mean, or how do we find slope in a coordinate system? Okay, let's move this up. If I were to graph, we're just going to do a sketch. 5, -6. And 3, -2, right? This would be my line. Okay, so what I want to do when I move up and down, that's my change in y. So my change in y would be 4, and my change in x would be going across. My change in x would be 2. My line is going down, which is negative, so therefore I have a -4/2 or -2. Okay, so just conceptually to understand it, because that's going to help when we get into the graphs. All right, midpoint. All right, so we're going to start with the midpoint formula. Okay, midpoint. We're going to add the x's together and divide by 2. And we're going to add the y's together and divide by 2. All right. You don't really need these brackets here, so why don't we just take them off for now. Okay. So we're getting the average of the x's, the average of the y's. So our x's, here's my xy 1s, my xy's 2. Okay, and the order doesn't matter because we are adding. When we're subtracting, we need to be aware of the order. So what we're going to get is -2 plus -11 divided by 2, which is -13/2. All right, and if we only need the midpoint, you don't have to simplify it. If we're graphing it, then you would want to simplify it. So the x value of the midpoint is going to be -13/2. And then we're going to have -9 plus 5/2, which would be -4/2. So if I had to actually work with the values in a graph, I would want to simplify them so that I would get a -6.5 or 6.5 -2. And that's the midpoint between the two given points. Okay? All right. The last thing that we're going to do is that we're going to find the length Now, sometimes in a graph, you can just use your Pythagorean theorem. If you're not graphing and you just want to use your formula, you have your distance is equal, let me put this bar here and make it a little bit easy to work with, a little bit neater, is equal to radical, all right? And what we said was the difference of the x's, doesn't matter which one is first and second, plus, squared, the difference of the x's squared plus the difference of the y's squared, okay? So we take a look at our xy, 1 and 2, right? So we have xy, xy, this could be our 2, and these could be our 1s, okay? And then we're going to have our distance is equal to radical. My x's are -4 plus 1 squared. And my y's are -5. Okay, hold on one second. I'm going to go back. This is -4 minus 1. Sorry about that. And this is -5 minus -2 squared. Okay. And what we're going to get is -1 minus 1 is -5 squared. Now put that in your calculator because I don't want you making mistakes with the calculator. Do that while we finish this over here. This double negative becomes a plus, so we have -5 plus 2, which is -3 squared. Now, if you put it in your calculator, -5 squared, without bracketing negative and 5 together, your answer would be a -25, which if you remember from last year, you can't have a negative until we do Algebra 2, which would be next year. But you don't want a negative inside your square root. So we're going to end up -5 times -5 is a positive 25, plus -3 times -3 is a positive 9, and our answer is radical 34. And you don't have to do anything. You don't have to simplify it. If it's a perfect square, I might simplify it. But don't simplify it because we're going to be using these values to compare our lines the same length, our lines different length. So our radical 34, we're just going to leave. Okay, I'm going to stop the video here, and they'll follow with a video 2.